All right, we are going to talk about graphing exponential functions. Now, we've already looked at how to graph them by a table of values, which of course, you can always graph anything by table of values, but we really want to look at this idea of shifting, kind of like we did with the quadratics, and we had the vertex and we shifted it left and right and up and down and stuff like that. So if you'll see up here, this formula looks very similar to the quadratic one that we did with the h and the k. So we're still going to be talking about h and k and shifting left and right. There are some extra things in there, though, that we're going to look at. So I want to look at this problem right here, and I've broken it down into several sections so we can kind of see what each component does, and then we will graph the whole thing all at once, but I don't want to do everything at once. So first, let's look at just what is the graph of y equals 2 to the x look like. So if I were to make an xy chart, because we need to start somewhere, and we'll just pick some numbers here, 0, 1, and 2. If I put 0 in for x, I get 1. If I put 1 in for x, I get 2. If I put 2 in for x, I get 4. And this is clearly not linear. So let's see, 0, 1, 1, 2, and 2, 4. It looks like that, and it's exponential. And I actually have the line here because I don't draw pretty lines. And it looks kind of like that. So this is what our basic graph is going to look like. And I'm not going to change kind of the shape of it. We're just going to be shifting this line around like this. Okay? So let's look at the first shift. That is our k. Okay, this on the end, it's added to. So if we look at this one right here, my added to would be plus 2. We've had in quadratics a line of symmetry. What we have in exponential functions is something called an asymptote. It is the lines that kind of help us see where to graph it. So I'm going to have an asymptote of y equals 2. So I'm going to draw one on here, y equals 2, right here. Okay, and I still have that same shape. I'm now, oops, I don't need it to do that just yet. I'm now just shifting it up to there. Now the one point I do want to make sure that stays there is this one here. Notice that when we did the graph down here, we had this kind of like our y-intercept was at 1, at 0, 1. It's now been shifted up 2. So if I look from here to here, I went up 2, and that's how I got to that point. You can also look at it like from my asymptote, this is going to be 1 away from it. So if my asymptote had been down there, my point would have been right here because that's 1 above it. And then I could have drawn my line like that. Okay, so the end, that number that's added to it at the end is our y asymptote, and it shifts it up and down. So if I had y equals 2x minus 2, then I would have had an asymptote down here at negative 2. Point is going to cross 1 above it, and then my line looks like that. Okay, so that's what that one does. And let's look at what the k or the h does, and that is when it's up here up top. And you'll remember from quadratics that one's plus and one's minus. So my x here is going to actually be a positive 2, not a negative 2. And this is another asymptote. So we have 2 asymptotes. Let me move this out of the way. So if I have an asymptote at 2, and I have x equals 2, so x equals 2 is a vertical line that goes that way. Since I have no k term on the end, then I'm just going to use this right here. So it kind of is like taking my axes and shifting them around. So I have one that's going horizontally and one that's going vertically. And then my point is still going to be just 1 above, but now I'm going to be on this new asymptote. Instead of putting it over here on this 1, right here, I'm going to shift it over 2. Okay, we had a shift of 2. It came over here, and it's on that asymptote. and then I can draw my line. Like that. That's not too bad. Let's see how I did. That's pretty good. Okay? Now the last number is that 3 that's in front of it. And if you're taking notes on your graph, just graph all these on top of the same graph, and then you can kind of see how it all shifts. This 3 right here. And what that 3 does is it actually moves that point right here. Instead of that going at 0, 1, okay, if I make another XY chart, and we'll do the same numbers, we did 0, 1, and 2 before. Now if I put a 0 in for the X, that's 1, but 1 times 3 is 3. If I put a 1 in for the X, I have 2. 2 times 3 is 6. If I put a 2 in for the X, it's 4. 4 times 3 is 12. But you'll notice that instead of being at 0, 1, now I'm at 0, 3. So I'm up here instead. However, I didn't shift. So it didn't move the point left or right. So my graph still comes down here and hugs this line. This is my asymptote and this asymptote here. Okay, so an exponential function will go on forever this way, up, and forever this way, but it will never cross my asymptote. This number will just continue to get smaller and smaller and smaller and smaller and smaller. If I go negative 300, I'm just going to have a really, really small number. See, if I put in here y equals 3 times 2 to the negative 300, right? And what does that negative exponent mean? Remember, we talked about negative exponents. It actually just means that you flip this upside down. So I have 3 times 1 over 2 to the 300. Well, 2 to the 300 is going to be a ridiculously small number, isn't it? And then I'm going to multiply that by 3. And all I've said is that I just have a really super small number, and I'm super, super close to that asymptote, but I'm never, never, never going to cross it. So when you're drawing your exponential functions, that asymptote is a guide for you. You want to start really close to it and then just curve up and make sure you hit the right point on your axis. All right, now that we kind of see what each of them does, let's look at this one here. Oops. At this point. So I'm going to have all of these things. So I am going to have x equals 2 and y equals 2. So I'm going to have an asymptote here and an asymptote here. And I know that this number means that I am shifting it over 2 and up to that 3, but my starting point was right here at this 3. So 1, 2, and 1, 2 up is right here. Or again, I can go, if I count 3 from my asymptote, 1, 2, 3 gets me there. And then my line is going to look like that. And that's it. So 3 parts that you need to look at. And here I wrote these down for you. So sketch the asymptotes, y equals x, and no, y equals k, and x equals h. Find the intercept for x is a. And then is it increasing or decreasing? We're gonna these are increasing. All the ones we just did are increasing. We're gonna talk about decreasing in just a minute. And then you just sketch your graph. Now the graph of an exponential can go through the same point. Whoops, that's not really the same point. It can be steeper, or it can really come up here and do this, but we're not going to get into too much about that. We really just want to be talking about the shifting and how that exponential function moves. All right, so drag the red star to translate the graph of y equals 3 to the x, 2 units up and 1 unit to the right. What is the equation of the translated graph? All right, so y equals, I know I have 3x here, right? And if I'm going to translate it 2 units up, that means I'm adding 2 over here. And if I'm going to translate it 1 unit to the right, that means I'm doing a minus 1. So that's my equation. And if I take my point right here, and that's the point I want to translate. So I'm going to translate it 2 units up, 1, 2, and then 1 unit to the right, 1 there. I know my graph's going to be something like that because my asymptote is going to be here and here. So there's where my graph is. And that's translating it 2 units up and 2 units to the right. So now, how is the graph of f of x equals 2 to the x transformed to create the red graph? So notice now that I have this blue graph, this looks like what we've been doing, the y equals 2 to the x, but this one's backwards. This is an increasing function, and this is a decreasing function. If you'll remember when we did them with the just an xy chart and evaluating, that if you have more than 100%, you're increasing, and if you have less than 100%, then you're decreasing. So what that means is that my function here, okay, we're looking at our a value, no, not our a value, sorry, our b, or our base. It's the base of my exponent, this part right here. If b is greater than 1, I have an increasing function, and it looks like this. If b is less than, whoops, I got to write less than 1, it's decreasing. But it can't be negative. So it has to be greater than 0. So this is increasing, and this is decreasing. Really, all it does is it just flips our graph around. Notice it still goes through the exact same point. When I do my shifting, it'll all be the same. It just means that I'm going to either draw it increasing or decreasing. So on our steps back here, number 3, is it increasing or decreasing? You'll decide that so that you know whether you're supposed to be drawing it this way or whether you're supposed to be drawing it that way. So an example might be, let's see, if I had y equals 1/2 to the x plus, or I'm sorry, to the x, I got carried away, plus 2. That would be a decreasing function because this number right here is less than 1 but greater than 0. I could also write it like y equals 2 to the negative x plus 2. And that's the same because remember, a negative exponent means that you flipped it, and if I flip a 2, I get a half. So a negative exponent is a decreasing function. A positive exponent is an increasing function. It just kind of plays out when we get rid of that negative that we end up having a fraction. So if I had y equals 3 to the negative x, that's the same thing as saying I have y to the 1/3 to the x. So it's a decreasing function. All right, so let's try this one. Y equals 3 to the negative x minus 2. Sketch the asymptotes. So my asymptotes are going to be x equals 0 because I'm not adding anything there, and y equals negative 2. So negative 2, I'm staying on 0, this one. Find the intercept since I don't have anything being multiplied. Now, don't be confused by this because I know you see a 3 and you're thinking, oh, it's 3. But remember, A is telling me that where that crossing is, where that intercept is, not the B. The B is the base of the exponent. The base of this exponent here is 3. The number outside being multiplied by this one is 1. So I just have a 1. Is it increasing or decreasing? Well, it's going to be decreasing because I have that negative, which means this is really 1/3 to the x minus 2. And then sketch our graph. So 1 means that I am 1 up from my horizontal asymptote, which is right there. And I have a decreasing function, so it's going to be coming down this direction. And I have a line there, but it won't work because it's backwards. Okay? All right, let's answer a few questions, and you can pause the video and answer these and see if you get them right. So which of the lines is the horizontal asymptote of this graph? The horizontal asymptote would be our right, would be this way. This is horizontal. That's our y. So it's y equals 0 because there's nothing being added to the back of this. It's just plus 0. The graph of y to the 3x is translated 1 unit up and 3 units to the right. What is the function represented by this? So 1 unit up, that's my x, or my y, excuse me. So that goes on the end. So it's going to be one of these two. And then I have to go 3 units to the right. But remember that that one is the one that's kind of backwards. So I would think right would be positive, but since our function is actually negative, it's going to be this one, h. Y equals 3 to the x minus 3 plus 1. All right, and that is it.